Welcome back, guys and gals. We're still in our 7th, 8th grade geometry unit. Today we're going to be talking about triangle basics, all right? Some of the stuff we're going to talk about today should be review for you. Other things might be new, so grab you a page of notes and let's get started. So first off, let's talk about different types of triangles, all right? Because there's not just one. So let's see here. We can talk about types of triangle. And we tend to classify, there we are, we tend to classify our triangles two ways, all right? The first is by angle, and then the second is by sides, all right? So here's what I mean by that. Let's talk about angle. We can have triangles that are called acute, triangles that are called right, and triangles that are called obtuse. And here's the difference. Triangles that are acute have 3 acute angles. So, for example, here is an example of an acute triangle. Notice all of those angles are less than 90 degrees. So this is an example of an acute triangle. Notice all these angles here are less than 90 degrees. All right? If we're talking about a triangle that is a right triangle, then it will have one angle that is equal to 90 degrees. So, for example, we could have something like this. We've been dealing with right triangles now for a little while in our Pythagorean theorem unit. And so there is an example of a right triangle. Notice there's our one right angle. So this is a right triangle. And then, of course, we could have a situation where we have an obtuse triangle. And obtuse triangles have one angle that is going to be greater than 90 degrees. So, for example, we could have a triangle that looks something like that. And notice in this case, our angle that's greater than 90 degrees is right here. Notice it's greater. So, obtuse. Now, notice that right triangles and obtuse triangles also have acute angles in them, but that's not the point. In order for you to have an acute triangle, all 3 angles have to be acute. So this would be an acute triangle. For right triangles, only one angle is 90. Again, you couldn't have more than that. And then for an obtuse triangle, one angle is greater than 90. And again, you can't have more angles than that being greater than 90 or the triangle won't work. And we'll talk about why in just a second. Let's talk about sides. All right. For sides, we have 3 classifications as well. So we can have what we call equilateral. We have what's called isosceles. And then we have what's called scalene. All right. And here's the difference. If you have an equilateral triangle, equa meaning equal, lateral meaning side or face, so equal sides means all 3 sides are equal in length. So, for example, there's an equilateral triangle. All 3 sides are the same length. And those little tick marks mean that each side is the same amount. Well, let's do that in red. So equilateral. All right. We also have isosceles, which means that just 2 sides are equal. Now, some people might refer to this as also being isosceles. Notice we do have 2 sides that are the same. Other people would say, no, only 2 sides could be the same. But again, that's up to interpretation. We're not too concerned about it for our purposes. A nice isosceles triangle, for example, could look like this. And notice we have 1, 2 sides there that are the same length, and then this side is different. So that's what those marks mean. Since these have the same number of marks, they're the same length, and since this is different, it's a different length. So this is isosceles. All right. And then last but not least, we have scalene. So we could just say that all sides are different. So, for example, a triangle, say like this, maybe a right triangle, but with all three sides being different. And again, scaling triangles don't have to be right. This one just happens to be. There we go. And this would be scalene. And we can mix and match these. So for example, I could have an isosceles triangle that's also a right triangle, or I could have an isosceles triangle that's also an obtuse triangle. So some of these will mix and match, all right? For example, let's try something like this. Maybe I've got a right triangle that's also isosceles. Let's draw one of those. So notice we've got a right angle here. We've got, say, isosceles in terms of the sides. So we would call this a right isosceles triangle. So part of what you'll be asked to do is to label different triangles, be able to identify what they are. And remember, we can do it two different ways. One is by angle, one is by sides. So all triangles have two classifications, all right? One by their angle and one by their sides, all right? And again, we'll do some examples of this in class. It's not terribly difficult. The hardest part, I think, is actually learning the spellings. But again, those will be on the page too. If you're like me and you're not a great speller, we can make it happen, all right? So let's talk about another idea. And this is one we kind of alluded to earlier. And this is about triangle sums. All right, we'll talk about that here. Triangle sums. Right? And here's the deal. All triangles interior angles will add up to 180 degrees every single time. Okay, and we call this idea the triangle sums theorem in a geometry sense, but we'll just call it triangle sums for our class. So here's what I mean. If I have just any old triangle, so I don't know, we'll draw something sort of nondescript here. And if I were to add up angles 1, 2, and 3, right? So let's give them some measurements here. So maybe angle 2, I don't know, just eyeballing that, I don't know, maybe it's 100 degrees, right? And maybe angle 3, I don't know, eyeballing that, maybe it's, I don't know, 40 degrees. Maybe 50 degrees. All right. According to the triangle sums, all three of these angles, so 1, 2, 3, all of them added together should get me back to 180. So if I know that angle 2 is 100 degrees and that angle 3 is 50 degrees, well, that means angle 1 has to be 30 degrees. Now, how do I know this? How do I know that for any triangle, this little idea works? Well, let's try something. I've got an index card here. Let's do a real quick experiment. I'm just going to make a triangle out of this index card. So I'm just going to cut kind of at random here. There we are. There's our triangle. All right. And I'm going to number all of our angles just like we did on our page. So here's angle 1, for example. Here's angle 2. Here's angle 3. Okay. And notice that since I cut this out of an index card, angle 2 is a 90-degree angle. So it's, notice, got that nice right corner there. And here's what I'm going to do. I'm going to tear all three of these corners off. All right. So don't be alarmed. Here we go. So I'm going to tear angle 3 off. There it is. We'll set it there. I'm going to tear angle 1 off. There we are. We'll set it there. And then I'm going to tear angle 2 off as best I can. There's not a lot of paper left. There we go. We'll throw that off to the side. So there are 3 angles. Now watch what I can do. I can rearrange these angles. And notice I get a straight angle. And if we go back to what we know, say, about a protractor, notice when we measure angles, we start at 0. So let's measure this angle. There we go. We start at 0 and we go all the way around. And I know it's not exactly on screen. Let me rearrange those quick. There we go. So there's our straight angle. Let's put this back down if we can keep it still. Not quite. If we go all the way around for our straight angle, notice we end up at 180 degrees. So this works for any triangle. If I take the 3 angles and I were to say cut that triangle out of a piece of paper and tear the corners off, every single time we can rearrange them and get this nice straight angle. In other words, 180 degrees. So if I know things about a triangle, for example, if I know, let's draw maybe an acute triangle this time. So maybe this side or this angle is 45 degrees, and maybe this angle is 60 degrees. How would I figure out this missing side, or missing angle rather? All right, well, the first thing I'm going to want to do is add the two angles that I know together. So in this case, 60 degrees added to 45 degrees is 105 degrees. Well, remember, we got 180 total. So if I take 180 and subtract the 105 I already know, that'll help me find what I don't know. So in this case, if I do that subtraction, I will get 75 degrees. So my missing angle here has to be 75 degrees. So we'll do more of these in class dealing with triangle sums. Some of them are very straightforward, like you see here. Some of them get more algebraic, but we'll spend time practicing these and they won't be a big deal. One other issue we need to discuss. Take a look. Oh, goodness. My pen sort of bled through there. Let's do this. We'll put it on a separate, we'll put it on a new page, a clean page. There we go. That looks better. So let's take a look at something. This is what we call, there we are. This is what we call exterior angles. All right, take a look. If we'll draw the example first and then we'll do with the talking points. Let's get a triangle drawn. I don't know. We'll do something like this. This will be nice. Okay, and I'm going to number the angles. Maybe. Yep, here we go. So we've got angle 1, angle 2, angle 3, and angle 4. Notice that angles 2, 3, and 4, right, will all add together to make 180. Again, the interior angles added together should equal 180. So I could say that the measure of angle 4 added to the measure, that's what that M means, measure, and then this little symbol, it kind of looks like a less than, that means angle. So the measure of angle 4 added to the measure of angle 3 added to the measure of angle 2 should equal 180 degrees. All right, but notice, I'm going to cover this up a minute. Notice angles 1 and 2 make a straight line. And remember, straight lines also are 180 degrees. Again, look at our protractor. Here's a straight line. And notice its angle measure is 180. If we went all the way around here, we get back to that 180 mark. So I could also say that the measure of angle 2 plus measure of angle 1 is also 180 degrees. Now I want you to notice something here. Angle 2 is in both of these equations. 180 is in both of these equations. So if all of these equal 180 and all of these equal 180, and notice that angles 2 are the same, well, then that means, guys and gals, and this will blow your mind, that angle 4 and 3 are worth the same as angle 1. All right, let me show you. Let's put some numbers in there. Let's assume that angle, I don't know, we'll keep with red. Let's assume that angle 1, I'm just eyeballing this angle. Let's say it's 140 degrees. All right. And angle 2 then, if this is 180, well, this would have to be 40 degrees. All right. Angle 3, as I'm looking at that, I don't know. That looks a little bit less than angle 1. I'm going to call it 120. So notice 120 and 40, that makes 160, which means angle 4 is only 20 degrees. Now let's try something. Let's rewrite this. Angle 4 we said is 20 degrees. Plus angle 3 we said was 120 degrees. All right. Plus angle 2 we said was 40 degrees. And all of that together equals 180. All right, wonderful. Let's look at angle 1. We said angle 1 is 140 degrees plus angle 2. Angle 2 we said was 40 degrees. Oop. And that's also equal to 180. So notice Angle 2 in both of these situations is the same. Here's angle 4. Here's angle 3. And notice if I add them together, it's the same as this exterior angle. So here's what we can write about exterior angles. All right. The exterior, that's this outside, this exterior angle of a triangle is equal to the sum of the two, if I could write today, of the two, we call these remote interior angles. So take a look. Remote meaning far away. So notice if this is angle 1, it's the exterior angle. Angles 3 and 4 are as far away as you can get from them. So that's what we mean by remote. And obviously interior, we mean on the inside. So if I take angles 3 and 4 in this case and add them together, that will be the same as angle 1. So let's try an example. Let's draw maybe a slightly different triangle this time. We'll do something maybe more like this. Maybe our exterior angle's up here this time. All right. So let's say, for example, that I know that this angle is 70 degrees. Maybe this angle is 80 degrees. What's that angle going to be? All right. And I'm going to show you how to do this two different ways. All right. The first way is what we just learned. All right. So if I wanted to find this missing angle, all right, it's going to be equal to 70 plus 80. So if I add 70 and 80 together, that gets me 150 degrees. So that's what our unknown angle is worth. So that's the quick way. Take these two remote interior angles, add them together, and automatically you get what's on the outside. All right. Let me show you the long way around. All right. Let's find this angle on the inside first. So if I have 70 and 80, add those together, I get 150. Remember, all three interior angles add up to 180. So if I take the 150 and subtract, that's 30. So this interior angle is 30 degrees. Remember, we said straight lines add up to 180. So if I take my 180 and subtract the 30 I know, well, what do you know? We're back to 150, which is exactly what we found the first time if we had just added them up. All right. So if we know the two remote interior angles, all we got to do is add them together to get this outside angle. In this case, 150 degrees. Very, very quick. Let's try another one. Maybe something like this time. This is crazy looking. All right. Maybe this interior angle, this is really small. I don't know. Maybe this is only 20 degrees. And maybe this one, I don't know. Maybe this is only 15 degrees. I don't know. That one's pretty small. What's our exterior angle? Well, again, the shortcut that we just talked about is take these two angles and add them together. So 20 degrees added to 15 degrees is 35 degrees. So cool. This outside angle is 35. All right, let's try one more. Let's see if we can, and we'll do it over here in our talking points section. Let's see if we can twist your brain. I don't know. Oh, I know. Let's do it upside down this time. Oh, yeah, we're going to get crazy. We're going to get crazy. Ooh, upside down. Look at that. All right, so let's flip it around even more. Let's say I know the exterior angle, so this angle's good size. Maybe it's 145 here on the outside. And let's say one of our remote interior angles is, I don't know, maybe this one, maybe this one's 50. All right. What's our other remote interior angle going to be? Well, remember, we said that if we add the two remote interior angles, that's equal to the exterior. All right. So if I take my unknown angle, add it to 50 degrees, we should end up at 145. All right. Well, this is just a one-step equation. We've been solving these for quite a while now. So all I'm going to do is just subtract 50 degrees from both sides. That'll leave me with my unknown angle. And in this case, we should end up at 95 degrees. Thereabouts. All right. Now, notice, I'm sure some of you are looking at this drawing and going, hold on, wait a minute, time out. If I take the 50 and subtract that from 145, all right, I'm okay with Mr. Lamar. I'm okay with you telling me that that's 95 degrees, but notice that is not a 95-degree angle. I mean, not even close. I mean, if we take a ruler out and measure it, Mr. Lamar, I mean, or protractor, we're not even close. It's an acute angle. What are you doing? Well, let me just remind you of something that I've had to teach all my students. Not all diagrams are to scale. Meaning that not all diagrams that you're going to see are drawn exactly as they should be. Okay, so keep that in mind. We're going to rely on what we know about the relationship here between these angles and the math to help us determine what's going on and not necessarily our eyes. All right, so be aware of that. If you're told a diagram is to scale, then by all means, judge that diagram to the best of your ability. But remember, not all of them are. So in this case, if I know that this is 45 and I know that this is 50, well, guess what? That has to be 95. And I know in this case that, hey, I just got a really crappy drawing, and that's okay. All right. If you've got any questions, make sure you bring them with you to class and we'll talk about it. Otherwise, guys and gals, you all have a good day.